Okay, so now we'll be discussing, you can say, a very useful pointer, which is the keyword this, right? And actually, it's a very simple concept, but it is very very useful, especially once you are writing large programs, right? So let me just explain this with the class that how what is this keyword this and how can you use it, right? So in order to explain, let me just make some class. I call it test, right? Because we are not discussing any special logic within this class. So you will have some data, whatever data you have, and then you will have some functions, whatever functions you like. Okay. Okay. So in the main program, as we always do, we know we can create some objects of this class like test t1, t2. Okay, and whatever data is maybe three data members, so t1 is somewhere in the memory and like t2 is somewhere in the memory, and they have some addresses, right? Now in the main, if we want to access the address of an object, we know we have this address of operator. We can do like this: cout t1, cout t2. Okay, so if the address was say 5,000 here and maybe 6,000 here, so you see these numbers on the screen, right? So in the main program, if you have an object and you want the address of that object, you use address of operator, right? That we already know. Now suppose you want to get the address of an object in a function which is inside the class. Okay, so what we are trying to say is, let's suppose I have a function void f, and I ask you that, okay, within this function, print the address of your object. Okay, means you have to write something here. Now you see you have these variables t1 and t2 in the main, so you cannot write t1 here. This, of course, it doesn't make sense because t1 is defined in the main, so you cannot use it here. Okay, and what do we want when I call this function like t1 dot f? What do we expect? We expect that this should print address of t1. This should print say 5,000. When you call this function with t2, we expect it to print address of t2, which is say 6,000. So in other words, when you are calling the function, you want to print the address of the current object. Why I am saying current object? Because when the function is executing, it is executing for a particular object. When you write t1.f, current object is t1. When you are on the statement t2.f, current object is t2, right? So for this, we have a keyword in C++. You also have this keyword in Java, I think. And that keyword is this. So in simplest, you can say form, you can define it as this holds address of current object, right? If, of course, you can write it inside the class, not outside the class. Okay, so when you are writing this, so you call this function t1f, your current object is t1, so this statement will print 5,000. When you call it with t2, so whatever is the address of t2, it will print 6,000. So in simplest way, in simplest form, you can define it as this is a keyword which holds address of current object. So in other words, it is actually a pointer. You see, because pointer is something which holds an address. So it is actually a pointer, but you see, you don't give it any value. It already has a value. And what value it has? It has address of current object. This is, you can say, the crispest way of defining how it works, right? Now, then you say, okay, it's fine, but where do we use it, right? So in order to, you can say, see where we can use it, let's do some example. Maybe again, a simple class. Say, let's change the class this time. Student. Okay, and you have some data. Okay, maybe student has some, say, name or ID or right? And then you will have integer enrollment number and maybe float GPA. And then within public, you can have some functions. Okay. Now suppose I make some function in the class, in the same class. Okay. Now within this function, if you write cout GPA, okay, whatever is the GPA of the student, it will be printed. But now you see, you also have an option. You can also write it like this. If you remember our discussion, this is the pointer. When you put static, it becomes object. So you can also write it like this, just like we were doing in the main. If you remember our topic on dynamic memory allocation, right? The only difference is that there we were using a pointer variable p. Okay, if you remember, you were doing like this, p dot, and then I told you instead of this, you can also use this arrow operator. So a third way of doing it is you can also write it like this. All of these actually mean the same thing, right? Normally this second one is not commonly used, so let's just skip it, right? If you write cout GPA, you are talking about the GPA, which is a class data member. If you write this arrow GPA, it again means the same thing. Now you would say, if I can do with this, why I would write like this, right? It will take more effort to write, and maybe you won't like to do that. Now let me convince you that why professional developers will always be writing this arrow GPA rather than GPA. Okay, so okay, let me write the constructor for this class. Okay, so the constructor would be student, and it will have three inputs. Why three inputs? Because I have three data members here. You must have noticed previously that in all the examples in which I am writing constructor, I take three variables like a, b, c. Okay, which is not a good idea. Why it is not a good idea? Because presently I only have three data members. When I will be practically making a student object to store your profile, maybe I have say 15 data members. ID, address, phone number, everything that you have when you fill the admission form. I need to store it, right? So you see, it means I will be making a long list of variable A, B, C, D, maybe K. This is name, this is ID, and then I need to remember, okay, D was for GPA, K was for phone number, and so on, right? So this is not a good idea. A better way is that if it's a name, then the variable name should also be the name. Okay, so what I will do is I will write string. So the first argument is actually a name, so I just write name here, which is the same as this variable. Sorry, this is not a semicolon, it's a comma. Let me correct it. Yeah, similarly, instead of calling it a, I am calling it name. Instead of calling the second argument enrollment, I am calling b, I am calling it enrollment number, so that I know it is enrollment number. And similarly, the third argument, I am not calling it C, I am calling it GPA. Okay. Now, if in the body of this function, you simply write name gets the value name, then what will happen? This name and this name, they both are referring to this variable. So you see this actually, which is the class data member name, it is not getting any value. This is syntax wise, it is correct. Your program will compile, but it is a logical error. You are copying the same variable in the same variable. So if you write enrollment gets the value enrollment, both of these variable are actually this one. We want on the right side to be the variable which is argument to the function, and on the left side we are talking about the class data member, right? So what people would do, that the advantage of keeping the same names is that you actually can correlate that this variable is for which data member. It has exactly the same name. When you want to talk about the class data member, you can do this arrow name gets the value name, which looks very elegant. Now the variable on the right side is actually this one, and the variable on the left side, this is actually this one. So you see now you don't have to change the names of the variable, and you have also ensured that you don't make a logical error in copying the values. And this arrow GPA is GPA. So you see this is a common way. Of course, you can do it with ABC or N, E, G, whatever you want. That is okay syntax wise, right? But as I keep reminding you that we don't want to write just correct programs, we need to write good programs, right? And this is a good way of doing it. Another thing that, of course, I'm not asking you that you should always do it, but if you see some professional code, they would have always done it. That whenever they are talking about class data members, they will use this. Okay, so that, for example, even if I'm making a function, say get function int, say get enrollment number. Okay, so you can easily write like this, return enrollment number. This is okay, right? There is no confusion, so no one is asking that we should use the keyword this. But still, instead of writing this, you will see many programs in which people would prefer to write it like this, which is exactly the same thing. Then why they are taking pain in adding this additional typing 5 different characters? Because you see, when you instantly do a walkthrough of the code, you look at the code, anything which is preceded by this, you instantly know it is a class data member, right? For example, in this function there are no other variables, but in some other functions you will also have some local variables, right? Maybe some temporary variables which are inside the function. So when you will see the keyword this, just by looking, or you can say globally looking at the code, you will instantly know what variables are class data members and what variables are the local variables of this function. Again, there is no, you can say, nothing will change from the viewpoint of your logic or algorithm or output, but this is just, you can say, your code would be more readable, that whenever we see the keyword this, we know we are talking about the class data member. So let me quickly do this in our class, right? So maybe rather than making a new class, let's just do it in this class. Okay, first let me just print you see out with this, so that you know that it is actually working. So I make a function print address in this class. Okay, and here I write cout address of current object. And what do I write here? I just write the keyword this. You see, it is a keyword, so it has the ID has recognized it and it has highlighted it. Okay, and maybe I can get rid of other functions so that you can see the main. Let me just delete them. Okay, yeah. So what we do is we take 2 points. Okay, and I write p1 dot print address, and I write p2 dot print address. What have we written in print address? Simply this. So when you call this function for p1, we expect it to print the address of p1. When you call it with p2, we expect it to print the address of p2. So let me compile this program, and if it works fine, I can share output with you. So this is our output window, right? Address of current object, the first statement is actually address of T1, or sorry, P1. The second statement is address of P2, right? And as we already discussed, these addresses are in hexadecimal, so that's why you see C, F, D. F is basically 15. It is just like, you can say, a number, only represented in hexadecimal rather than integer in base 10. Okay, so this is okay. Okay, now suppose I make another function, say void print x. Okay, let me just print the variable x in 3 different ways. So I can write cout x, and I can also write cout static this dot x. The second one is not preferred, but just for completeness I am writing, so that if you see it in some book or on the internet, you should know that this is also legal. So you see, I have written 3 statements. And all of these are actually doing the same thing. They are printing the value of x, right? So maybe you can now call this function print x. Okay, and if you run it, then we expect all three to give you the same output, right? So for p1 the x coordinate was 2, so all the three statements are showing you 2, 2 and 2, right? Because they are all referring to the same variable. One last thing which we did, that okay, this printing is not very useful. The actual thing which can be useful is that instead of calling, I'm going to the constructor, and instead of using a b c or anything else, I'm using the same variable names x and y. Okay, now you see, as I told you, if you write x gets the value x, y gets the value y, syntax wise it is okay. There is no syntax error in this. Okay, means your program will compile, it will not give you any error. But you see, it is a logical error, that when you write x gets the value x, you are copying 0 back into this 0, which is the input to the function. You are not copying this value in the class data member. If you want to do that, you can write this arrow x gets the value, and this arrow y gets the value y. So on the left side you have x, which is class data member. On the right side you have x, which is passed as an argument, and same goes for variable y. Now you can call this constructor and you can convince yourself that it is actually copying your data into the class data members. Okay, one last thing for today, which is not something new. I hope we all, or rather, I assume that you actually know this, or you have been doing this. But just to be very sure, I will explicitly discuss it. Right? You see, we make functions in the class, and we call those functions from the main. Right? But in the very initial days of our semester, when I told you about that encapsulation concept, and you have data and functions, so within a class anything can access anything, right? So it means that a function inside the class should also be able to call a function in the same class. Okay, we did not do an example which is doing this, but this is something that is understood, it should happen, right? We have been calling from function from the main, but it is also possible that you can call a function from another function in the class. So let me just do it, and let me tell you how this can be useful and why we want to do this. Okay, so let me make just set function. So I will make a set function int x, int y, and here I will say gets the value x, and sorry, this y gets the value y, something like this. Okay, so you also have a function set x, void set y. Sorry, yeah. So you say this arrow y gets a value y. Okay, now you see the statements you have written in the constructor, they are same which you have written in the set function. And these are only two statements, but it is possible there are 200 statements, right? You are doing some error checking, maybe it is a time class, you don't want a illegal value less than 0, greater than 23 or 59, and so on, right? So it means that whatever you are doing in constructor, you will have to repeat that in the set function. So why not, instead of writing this, I can call the set function from here, just like this. You see, I don't need any object because I am calling the function from within the class. So you will call it just like you call a regular function. So now what is happening here? Let me just explain. When someone will make an object, point p to 3, they are calling the constructor. You come here, x is 2, y is 3. So instead of writing these statements, since they are already written a function, we call the set function. Now this set function is actually the function of the same class. So it will pass this x to this x and y to this y. And here you are doing this thing. But you can say, okay, what I was doing here, I'm also doing it here. So why not call set x and set y from this function? Okay, this is also possible. Of course, all of these are correct. I'm just sharing with you the different possibilities that you can do. So you can say that, okay, why not, instead of these statements, I again call functions from this set x and set y, which is perfectly fine. So now you see, you are reusing the functions of a class from within the class as well, rather than only calling the functions from the main. Now in the main, you have given user many options: constructor, a set function with two arguments, a set function for only x and y. But within the class, you see, since it was the same thing, so we have tried to reuse the existing functions as much as possible. Okay, so this is something that you should make a habit of. And similarly, you see, in the beginning, some of the students were asking, can I make a function private? So yes, you can make a function private, and then you can call it from the class only, not outside, right? For example, if I make set x and set y functions private, okay, so it means, let me just cut them from here. Let me paste them in the private section. Okay, so now what will happen is you have two functions which are private. So from within the class, right? When I say within the class, so it means any function inside the class, it can call these functions. So this is a set function. Now I can call these functions because I am inside the class. But from the main, you will not be able to call this private function. You cannot call, you can call p.set. This is fine. But if you try to do p.setx, then this will not work because the set x function is private. Although we don't do it normally, functions are public and data is private, but sometimes there are some functions which are utility functions, which are only for you to make your program more organized. You don't want user to directly call those functions, so you can perfectly make them private as well. And you see, just like you were doing with data, when you are calling a function of a class, you can call it with name, but no one is stopping you from doing this. You can call a function with this as well, because after this an arrow, you can write any member of the class, whether it is function, whether it is data. So it is also possible. You can use this here. It's your choice, you want to use or not, but it is allowed. Okay, if you find it difficult in the beginning, you can just do the conventional way. Otherwise, it's better that you make a habit of, whenever you are calling a function of a class or you're referring to a data member, it's a good idea that you use the keyword this, right? So with that, I'll stop for today, and we have some time. So if there are any comments or queries, we can discuss.